Hey guys, in this video, I'm going to show you exactly how to rationalize the denominator. We're going to go through a few questions. We're going to look at some easy ones, some intermediate ones, and then some difficult ones. So this is a skill required of you pretty much in all levels of mathematics. It's a fairly foundational skill, I would say. Well, hopefully by the end of this video, you'll be a lot more comfortable with rationalizing the denominator. Okay, so let's start with this first example over here. So when you have only one term on the denominator, rationalizing the denominator is fairly simple. All you need to do is to multiply both the top and the bottom by this number. So I'm going to take the example over here. So I'm going to multiply the top and the bottom, right? The top and the bottom by the square root of 7. And then just multiplying across as you would with fractions. 1 times the square root of 7 is root 7. And root 7 times root 7 is 7. And so that has been rationalized. We'll do example B. So we're going to do the same thing. We're going to multiply the top and the bottom by the denominator. We're only going to multiply it by the square root of 2. And the reason is because that is the irrational part of the question. We could multiply it by 2 root 2, but there's no need to multiply the 2 because the 2 is already rational. It's the root 2 that's irrational. So we're going to multiply the top and the bottom by the irrational part, which is the square root of 2. And then we're going to follow through the same thing. So the square root of 3 times the square root of 2 is the square root of 6. Now 2 times 1, right, is 2. And root 2 times root 2 is 2. Now just simplifying the denominator is 2 times 2, which is 4. And this is a solution. And obviously we can't simplify the 4 with the 6 because this is rational and this is irrational and they can't be simplified. So let's try this question now. Let's call it C. So similar to the previous question, we're going to multiply the top and the bottom by the irrational portion of this denominator, which is the square root of 5. So root 5 over root 5. Now, because there are 2 terms on the top, we just have to be careful and ensure that we're multiplying root 5 by each term. So the square root of 5 times 4 root 3. So first we multiply the irrational parts. So 4 times 1 is 4. And then root 3 times root 5 is root 15. And then 2 times 1. And then root 2 times root 5. And then 7 times 1. And then root 5 times root 5 is obviously 5. And 7 times 5 is 35. And so this now has a rational denominator. Okay, so let's look at an example where the denominator is not one term, but it's 2 terms. So we call this a binomial denominator. So this is a little bit different. And in this case, in order to rationalize the denominator, you need to multiply by the conjugate. Okay. So what is the conjugate? I'm sure you've heard of this term before. So with the conjugate, I guess the easiest way to define the conjugate is it's the expression that is opposite in sign to this expression. So if this expression is root 3 plus root 2, then the conjugate of this would be root 3 minus root 2. So all you do is you swap the signs. I'll give you another example. So if you have, for example, let's say the square root of 3 minus the square root of 5, the conjugate of this would be the square root of 3 plus the square root of 5. So these values kind of stay the same, but it's just the sign here that changes. So that's the definition of the conjugate. So in example A, in order to rationalize a binomial denominator, you need to multiply the top and the bottom by the conjugate. So as we discussed previously, the conjugate of this denominator is square root of 3 minus the square root of 2, and the square root of 3 minus the square root of 2. Now we simply expand. Just be careful, this is 2 terms, so we're going to multiply the 4 by the root 3 first to give us 4 root 3, and then we're going to multiply the 4 with the minus root 2 to give us minus 4 root 2. Then the denominators. if you look really, really carefully, what you notice about these two factors is that they create a difference of two squares. And so when you expand a difference of two squares, there's a little shortcut that you can use. So all you need to do is square the first term. So the square of root 3 is 3. You put a minus in between, and then you square this second term. The square of root 2 is 2. And that's how you expand a difference of two squares. Now, with the top, there's no way we can simplify that anymore because we can't simplify these surds. So we simply write it as it is. And 3 minus 2 is 1. So we can just write this without the denominator. All right, let's have a look at example B. So we're going to do exactly the same thing for this example. We're going to multiply the top and the bottom by the conjugate. So take a moment and have a think, okay, what is the conjugate of this denominator? So root 2 minus 7. So we're going to apply the same logic that we did in the previous question. We're just going to replace this middle symbol with the opposite. So the conjugate of root 2 minus 7 is root 2 plus 7. And now we're going to expand the top. So root 3 times root 2 is root 6. And root 3 times 7 is 7 root 3. Now, once again, we have a difference of two squares. So in order to expand a difference of two squares, we square this first term. So the square of root 2 is 2. And we square the second term. The square of 7 is 49. We simplify the top if we can. In this case, we can't. So I'm just going to rewrite it as root 6 plus 7 root 3. Then we simplify the bottom. 2 minus 49 is minus 47. And that's your answer right there. You can rewrite this answer with the negative at the top, but it's not necessary. All right, I hope you're getting the hang of this by now. So we're going to do the same thing as we did in the two previous questions. We're going to multiply the top and the bottom by the conjugate of the denominator. And so what is the conjugate of the denominator? Well, we're going to keep the same values, but we're going to replace this sign with a negative. Okay, so we're going to times the top as well by that same expression. I'm going to put them in brackets just because they're because they contain more than one term. Now we're going to expand. The way that we're going to expand the top is we're going to use eyebrows. So we're going to do 3 root 3 times 2 root 5. So I'll write it out like this, right? Then we're going to do 3 root 3 times negative 3 root 2. Then we're going to do root 2 times 2 root 5. And then we're going to do root 2 times negative 3 root 2. Then we're going to do the denominator. So once again, it's a difference of two squares. So we're going to take the square of the first term. I'm going to write it like this. We're going to minus the square of the second term. Okay, it looks a bit crazy, but don't be intimidated by this. You just simply have to use a little bit of algebra to finish this off. So we're looking at the first one over here. So we're going to multiply the rational numbers first. So 3 times 2 is 6. And then root 3 times root 5 is root 15. Same thing here, we're going to multiply the rational numbers first. So 3 times negative 3 is negative 9. And then root 3 times root 2 is root 6. The rational numbers here, so that would be a 1. So it's basically just 1 times 2, so that's 2. And then root 2 times root 5 is root 10. And then once again, there's just be a 1 there. So 1 times negative 3 is negative 3. Root 2 times root 2 is actually 2. So we're going to multiply the 3 by the 2 to get a 6. Now we're going to square these terms. So we're going to square each one. So the square of 2 is 4. And the square of 5 is 5. The square of 3 is 9. And the square of 2 is 2. Now, we're going to have a look at the top and see if we can simplify anything. And by the looks of it, there are no like terms, and therefore we cannot simplify. So I'm just going to rewrite it as it is. And the denominator, this will give you 20. This will give you 18. So 20 minus 18 is 2. What you also got to think about is if you can factorize the 2 out of any of the terms at the top, and you can factorize the 2 out of 3 of these terms, but not out of this term. And therefore you can't cancel any 2's at the top with this 2 at the bottom. So just be mindful of that.